Hey everyone, and welcome to today's Explainer. Have you ever stopped to think that the bright, sparkling smile you get from your morning toothpaste and the heavy metal bus you ride to school both actually share a common, hidden secret? It's true. They rely entirely on minerals. I mean, from tiny little pins to towering skyscrapers, minerals are the absolute foundation of human development. And today, we're going to master exactly how they work.
Okay, let's dive into this. Here's our roadmap for the Explainer. We'll start with what are minerals, then look at how minerals are formed, followed by classifying our mineral wealth. After that, we'll tackle mining hazards and conservation, move on to powering up with energy resources, and finally, wrap it all up with a chapter review and quiz.
All right, Section 1, what are minerals? Literally, the building blocks of our everyday lives. To really grasp how important they are, I want you to consider this number, 0.3%. Our daily mineral intake represents a tiny, microscopic 0.3% of our total nutrients. But here's the wild part. They are so potent and so incredibly essential that without that tiny fraction, our bodies literally wouldn't be able to use the other 99.7% of the food we eat. Life processes just wouldn't happen without them.
So that kind of begs a pretty fundamental question, right? Think about it for a second. If you had to define the rocks, the crystals, and the metals beneath our feet, what exactly is a mineral?
Well, geologists actually give us a really precise definition. They say a mineral is a homogeneous, naturally occurring substance with a definable internal structure. Okay, let's break that down into plain English. Naturally occurring just means nature makes them. Humans don't. Homogeneous means they're consistent all the way through, and a definable internal structure means their atoms are arranged in specific, highly ordered patterns. It's like a giant microscopic puzzle, and it's exactly why we have minerals ranging from the super hard diamond to the incredibly soft talc. Let's move on to Section 2 and see how this all builds up, how minerals are formed moving beneath the Earth's crust. So minerals usually hide out in what we call ores, which are just mixtures of minerals and other elements, and they generally form in four main geographical ways. First off, in igneous and metamorphic rocks, liquid or gaseous minerals get forced upward into cracks. The small cracks are called veins, and the larger ones are lodes. Second, in sedimentary rocks, they form in horizontal beds or layers through things like deposition and evaporation. Third, we've got placer deposits. These are found in valley sands where water doesn't corrode them. Think of panning for gold or silver. And finally, our vast ocean waters actually hold widely diffused minerals like salt and magnesium.
On to Section 3, classifying our mineral wealth. It's time to organize these geological treasures.
Now, with over 2,000 identified minerals out there, geologists and geographers have to classify them just to make sense of the Earth's crust. We broadly split metallic minerals into two main camps: ferrous minerals, which contain iron, and non-ferrous minerals, which don't. Now, what's really interesting here is that ferrous minerals actually account for a massive 3/4 of all metallic mineral production. They act as this incredibly strong base for our whole metallurgical industry. Let's map this out across India, putting some real-world uses to these names. Iron ore? That's the industrial backbone, absolutely vital for steel, found largely in states like Odisha, Jharkhand, and Karnataka. Manganese is also crucial for making steel, plus things like bleaching powder. Then we have bauxite, which is this clay-like substance that gives us aluminum, super prized because it's incredibly light but really strong. And finally, mica. Found mainly in Jharkhand and Rajasthan, mica is a real game changer for the electronics industry because of its amazing insulating properties. You know, there's a historical anecdote that brilliantly illustrates how human innovation completely changes the value of a resource. Get this. Shortly after aluminum was discovered from bauxite, Emperor Napoleon III proudly wore aluminum buttons and served his absolute elite guests on aluminum plates. His lesser, everyday guests, they had to eat off plain old gold and silver. I know, no way, right? But fast forward just 30 years, and aluminum production had become so efficient that aluminum bowls were common with the beggars in Paris. The idea of its value completely flipped. Let's jump to Section 4, mining hazards and conservation. What is the real cost of extraction? We kind of have to shift our tone a bit here to talk about the harsh realities of getting these resources out of the ground. Mining is, tragically, sometimes called a killer industry, and for good reason. Miners are constantly inhaling toxic dust and noxious fumes, which makes them highly vulnerable to severe pulmonary diseases. They face the daily nightmare of collapsing mine roofs or sudden inundation and fires in coal mines. And it's not just the miners. Dumping waste and slurry leads to massive water contamination, soil degradation, and river pollution. We desperately, desperately need stricter safety regulations. So, the crucial point I want you to remember from this is the number 1%. The total volume of workable mineral deposits makes up an absolutely insignificant 1% of the Earth's crust. That's it. We are rapidly chewing through resources that took the Earth millions of years to create. They are finite and they are non-renewable. If we just keep extracting without care, costs are going to skyrocket and quality is going to plummet. Conservation and sustainable technology, they aren't just buzzwords, they are absolutely vital.
Okay, moving to Section 5, powering up energy resources, the spark that drives our world. So, we've talked about the rocks we dig up, but now let's talk about the energy that powers our homes, our trains, our industries, the whole shebang. We divide energy into conventional sources, so your firewood, coal, and petroleum, and non-conventional sources, like solar, wind, tidal, and atomic energy. Now, in rural India, an estimated 70% of energy needs are still met by firewood and dung cakes. But with our forest areas shrinking, we really have to shift our focus toward those abundant, renewable, non-conventional sources. If we look at conventional energy, coal is by far the most abundant fossil fuel in India. It's basically a geological pressure cooker. It forms by the compression of plant material over millions of years, and it grades up based on heat and pressure. First, you get peat, which has low carbon and high moisture. Next up is lignite, a soft brown coal. As you dig deeper and crank up the heat, you get bituminous, which is the most popular coal for commercial use. And finally, under maximum pressure, you get anthracite, the absolute highest quality hard coal out there. But hey, human innovation is shaping our future with non-conventional sources, and it's pretty amazing stuff. Take atomic or nuclear energy, for example. We're literally altering the structure of atoms to release massive amounts of heat, using elements like uranium and thorium found right in Rajasthan and Jharkhand. Or consider tidal energy. We build these massive floodgate dams across ocean inlets. When the high tide rushes in, we trap that water. When the tide goes out, we release it through a pipe, and the sheer force of that rushing water spins a power-generating turbine. How cool is that? All right, let's bring it all home with Section 6, Chapter Review and Quiz. It is time to test your mastery. Okay, here's your first rapid-fire textbook exercise question. Which mineral is formed by decomposition of rocks, leaving a residual mass of weathered material? Is it A, coal, B, bauxite, C, gold, or D, zinc? Go ahead and lock in your guess. Did you get it?
The answer is B, bauxite. Unlike a lot of minerals that form in vans or beds like we talked about, bauxite deposits are uniquely formed by the surface decomposition of rocks that are rich in aluminum silicates. Great job if you remembered that one. All right, let's try exercise question 2. Think back to that regional map we discussed. Koderma in Jharkhand is the leading producer of which mineral? Is it A, bauxite, B, mica, C, iron ore, or D, copper? And the correct answer is B, mica. And this brilliantly illustrates why knowing your regional geography really matters. Koderma is basically a massive storehouse for mica, which, if you recall, splits into incredibly thin leaves and is an absolute lifesaver for the electric and electronic industries because it completely resists high voltage. Man, we have covered an incredible journey today, haven't we? From the deepest lodes beneath the Earth's crust all the way to the tidal waves generating our electricity. But I want to leave you with one final, absolutely vital thought. We only have that 1% of workable mineral deposits. 1%. So how will you help conserve our finite resources for the future? Think about your everyday energy use, the products you buy, and maybe even the sustainable innovations you might one day create yourself. Thank you so much for joining me on this explainer. Stay curious, keep learning, and I'll catch you next time.